Well, hello to my favorite people, and how are you? How's it going? And thank you for watching this lecture video. I'm here with another lecture from organic chemistry. In this lecture, I will show you what will happen if we add acid to an ether. An ether molecule that you pick is going to have oxygen with two lone pairs in the middle of the molecule. And because of those two lone pairs, it's capable of getting involved in, technically, proton transfer. It will take H plus from acid, and it will give you an intermediate that is a protonated. And because it's a protonated, that's intermediate, it will not be stable. Okay, now we will have oxygen with a positive charge, and because oxygen, it has higher electronegativity than carbon, it will pull electron density from the carbon atoms. So those two carbons now do have partial positive charges, and because of that, they can get involved in the nucleophilic substitution reaction. And so X, which is one of the product of the reaction, and it will get involved in second step. It will be added to the intermediate as a nucleophile. Now we turn neutral oxygen to a species that it has a positive charge. So oxygen is not happy. Very soon oxygen is going to take those two electrons and will leave the system as a neutral compound. So now the charge on it is 0 and oxygen will be happy, and that's going to be alcohol. And other product, it will be the alkyl halide. You need to be careful about where to add the halide. In this case, because I have two methyls, okay, it doesn't matter which carbon we attack, okay, and it's an SN2 reaction. We know SN2 reaction. For SN2 reaction, methyl will be preferred over a primary, and primary over a secondary, and secondary over a tertiary. Okay, so because I have the methyl on both sides, it doesn't matter which carbon we attack. But what will happen if we have different methyl, technically carbons on right and left side of the oxygen atom? So, for example, let's say we have isopropyl attached to oxygen, and other side I have a methyl. Okay, I'm gonna say this is a secondary carbon. Well, this one is CH3 or methyl group, and if you, let's say you add hydrogen there, now we have a positive charge plus one charge there. Okay, and the nucleophile can attack. Okay, the nucleophile can technically attack this carbon, and if attack that carbon, then oxygen will take those two electrons, will leave the system, or it can attack this carbon, and then those two electrons will be given to oxygen and we'll get methanol. Okay, so if we attack carbon number 1, or the one on the right side, and we will get this CH3 and then X or the halide, and also we get this alcohol, okay, the isopropyl alcohol. Or if we attack the secondary carbon, in that case we will get the halide attached to the isopropyl, plus we get methanol, CH3 OH. Which one is going to happen? The one on the right side. And what's the reason behind it? This is a SN2 reaction. SN2 reaction will favor the carbon with less substituent. So the right side is going to happen, left side, no. Now, the acidic cleavage, it can happen when you have a primary, we have a methyl, primary or secondary. But if like if you have a tertiary carbon, and then the mechanism will go through SN1 instead of SN2. Or if you have, let's say you have a conjugated system, let's say, forgive me, a ring or a double bond involved, in that case, SN2 reaction will not happen. And the reaction prefer to go through different mechanisms. Okay, so for example, forgive me, in this case, I have a secondary carbon attached to oxygen, and this side I have CH3. Okay, first step of this reaction, oxygen will go after hydrogen. Why? Because hydrogen, it has a positive charge, and so oxygen is going to share the lone pair with hydrogen, and we get such a intermediate. We get oxygen there, oxygen now attached to hydrogen, has only one lone pair, and we do have the methyl there. So now we have a positive charge there. This again, this is a primary, secondary carbon, while the one at the bottom is just a methyl group. Now, what will happen if you add the nucleophile? And what's a nucleophile? Nucleophile in this case is going to be the iodide. The iodide, it can attack either this carbon, the secondary carbon, or the methyl carbon, and the reaction is going through SN2 mechanism. Okay. And if that one happen, in that case, we will get this. Okay, so this is our intermediate. And the reaction is going to go through, and it's going to go after, forgive me, after methyl carbon, and this one is going to happen. Well, the top one, it will not happen. So I will get this product. These two electrons, those two electrons, technically, they will stay attached to oxygen, so nothing will happen to them. But these two Okay, these two will give them to oxygen, and oxygen it will leave as alcohol. So here you go, I have oxygen. Okay, and now with hydrogen and oxygen, it will have two lone pairs. So I got alcohol. Another product, it will be the CH3 attached to iodide, and iodide was our nucleophile. Okay, now question is, what's going to happen to the alcohol? It depends to the concentration that you use. If I go back here and they said that we apply the acid plus heat because we need to have heat to speed the reaction. And then they did not mention how many moles from iodide, H iodide they used. Okay, assumption is going to be 1 mole. Okay, 1 mole from HI. Okay, if they don't mention anything. And so I'm going to say if they use only 1 mole from acid in the presence of heat, in that case, we will get alcohol plus alkyl halide. Now, what will happen if we use excess from the acid? Okay, if you use excess from the acid, in that case, this alcohol, it will get involved in another reaction. So again, we're going to add HI to it and also heat. And heat we showed by this triangle. And so I go heat. So first step of the reaction, we will get this one. We'll have oxygen, and oxygen was attached to 1 hydrogen. We're going to add another hydrogen to it. So now it has only 1 lone pair, and it has a positive charge plus I minus. Okay, now what will happen to the I minus? I have only 1 carbon, and that carbon is a secondary carbon. So this time we have only 1 option to attack. It will attack that carbon, and oxygen, it will take those 2 electrons. So those 2 electrons now, they will be taken by oxygen, and oxygen will leave the system as water. So I get water plus this product. Okay, so I got iodide or alkyl halide. And again, if I go back, if they give us only 1 mole from HI plus ether, we get alkyl halide. The halide will be sitting on a carbon with less substituent, and alcohol, and it will be sitting on a carbon with more substituent. Now, if you add the second mole of the acid, and the acid, it will go after the alcohol, and it will turn it to alkyl halide plus water. What will happen if the starting compound, one side of the starting compound is a tertiary carbon, and so let's say here we have a tertiary carbon, and this one is just a methyl group, and we are adding acid to the system plus heat. So I'm going to say this is going to happen. I will just simply add the hydrogen to oxygen, and oxygen now it has only 1 lone pair, is attached to CH3. Oxygen, it has a positive charge, is not going to be happy because it's of the positive charge. And so it's capable of actually getting involved in some chemical reaction. But can we have SN2 reaction, or the reaction is going to go through SN1? Okay, we have to refer again back to the carbons that we're dealing with is a tertiary carbon. So that means this oxygen very soon, it will take those 2 electrons and it will leave the system and it will give us this. We get a tertiary carbocation plus CH3 attached to oxygen, and oxygen attached to hydrogen. So we got alcohol plus carbocation. Now, and the question is, what's going to happen to this carbocation? This carbocation is going to get involved in SN1 reaction. And what's going to be the nucleophile? The nucleophile in this SN1 reaction, it will be the Br-1. So next step, Br-1, it will be added to the tertiary carbon, and it will give us alkyl halide. Okay. Again, as I said, this one is going to leave the system, and it will give us this intermediate plus CH3OH. I mentioned this one. And then now this intermediate, it will react with the bromide as a nucleophile, and this is going to be our final product. Okay, so we got this product. The first product that we had was that alcohol. This is the second product. Okay, now because they did not use excess from HBr, the reaction is going to stop here. So the final product, will be alcohol, methanol plus the 1-bromo 1-methyl cyclohexane, or the second product. Now, if you use it, two mole or more, excess of HBr, in that case, you will get 2 products. The first product, it will be CH3, because it has less order, the halide will be attached to it, so bromide it will be there. And as the second product, it will be this. Okay. I think I switched it. I'm sorry. Okay, so we said we have methanol and bromide. I'm sorry about it. We had methanol here, and this one is the bromide. Okay, now what will happen to the first product? This first product, it will get involved in another reaction. So now HBr, it will be added to it, and it will give us this. And now next step, Br minus 1 is going to behave as a nucleophile. Now we will have SN2 reaction. So the first product is going to get involved in an SN12 reaction, and the bromide will go after this carbon, and oxygen will take those two lone pair. It will leave the system, and we get this one as final product, CH3 attached to bromide plus water. Okay, so technically, I removed the oxygen atom, this oxygen atom, I removed it, and I just simply attached the iodide or a bromide to both actual carbons. So let's write the final product. The final product will be this. We're gonna take this compound, and we will erase the oxygen atom. So let's erase the oxygen atom from both sides. Then we will have bromide attached to both of them. So that's going to be the final product when you have excess from the acid. Okay, and this is going to be the end of this lecture, and thank you very much.